So this would be a quick run through of lesson 4 on graphing from intercept form of a parabola. They could call this form right here uh, x-intercept form, and I think that's probably more appropriate because as you can see right down here, when you're in this form, uh, the p and the q are your x-intercepts. Right? X-intercepts always have y values of 0. And so if you can figure out what p is, you just go p comma 0, and that's where it crosses the x-axis at. Okay? Some other things to note about it is like, hey, if I know my p and my q, which this form tells you, then I can just add them together, divide by 2, and that tells me the axis of symmetry. Then here's our vertex notation where, hey, the axis of symmetry, it tells you what x is. That's the x of your vertex. And then right next to it is the y coordinate for the vertex. And it just says, take the function, whatever your equation is, and put this number, that x in, so you can find out the y coordinate that goes with it. So there's your x, plug that number into the function, that gives you your y. Y-intercept, plug in 0 for x, uh, and that will tell you the y value that it crosses at. And I think that's about it. Maximum when it opens down, minimum when it opens up. Look for that y value at the vertex. Okay, so I'll just run through these. These aren't too bad. Here's just our parent function. We always put this one on here, or I try to, just to get you guys in this mode of, hey, there's no shift left or right. There's no shift up or down. This is just the parent function. It starts at the origin and it does that 1, 3, 5, right? Left 1, up 1, left 2, 1, up 3, then, or another move right and another move up 3, then up 5. There's the 1, 3, 5 method. I went right 1, I go up 1. I went right 1, I go up 3. I went right 1, I go up 5. And that'll always give you the correct shape. Finally, in vertex form, remember vertex form, a times x minus h. We've been working on this one to death. The a values, the number in front, it's just a 1. X minus the h of the vertex, which is 0, and the k of the vertex is 0. Remember your vertex, 0, 0, is your h and your k values when you're in vertex form. This would be a really silly way to write this equation, though. Y equals x squared, just your parent function. If we write it like this, we say, hey, vertex at 0, 0, and then it looks just like 1x squared. All right, so let's move on to our next demo here. Let's see here, find the x-intercept. So I'm going to throw this up here. A times x minus p times x minus q. Now, they call these things the x-intercepts, and they are indeed that. And we do have this thing called this intercept form. But what I want you to notice is that like right away we can go p is equal to, get rid of a little tick mark there. Right away we could go p is equal to 1 and q is equal to 5. Sometimes we have a hard time figuring out the p's and q's, like down here when it has a plus sign, people forget. So here's a little rule. All you're trying to do is find out what makes the x value into, or this factor x minus 1 into a 0. And if I just write that little equation and solve it by adding 1 to both sides, it tells me the x value that makes this equal 0. And really, that's what I'm trying to find, the x values that produce a y value of 0. And it just turns out that, if I can figure out what makes this little factor, x minus 1, 0, then I can find out what makes the whole polynomial 0. Because once this one becomes 0, 0 times, regardless of what this is 0. 0 times anything is 0. So the other one, like x minus 5, I could just take x minus 5 and say, what makes you equal 0? And it tells me. And so right away, I can say, well, when x is 1 and when x is 5, that function equals 0. Okay, those are your x-intercepts. Right? I write them as ordered pairs. So I could put like 1, 0, and I could put 5, 0. Axis of symmetry, we've talked about this one right up above there. Just add the two x values and divide by 2. We're only looking for the middle because if this is a parabola, which we know it is, x times x, it's an x squared equation, then it makes a parabola, and the parabola splits the curve, or the axis of symmetry splits the parabola in half. And so I've got to have an axis right in the middle of those 2 points. Don't put a point there. The axis is a vertical line. Vertical lines have equations, and this equation is x equals 3. And I can put arrows on it. This thing goes on and on forever, splitting my parabola in half. Okay, so I'm going to do the math over here. 1 plus 5 divided by 2 is 6 divided by 2 is 3, right? The same thing I got by doing it visually and just looking at the graph. All right, last question is where's the vertex? The vertex, everybody, if you remember, is at p plus q over 2, comma, f of p plus q over 2. All righty, well, p plus 2 over q, I just found that. And so this is really what I'm trying to calculate. I know the x is 3. I need to find the f of 3. What happens when I put the 3 into the function? All right, so here's how we would notate that. F of 3. Oops, I shouldn't be using f, sorry. I'm going to use g because this function is a g up here. All right. Everybody, this function I've been using a lot and I keep writing it down. It means put the 3 in for the x, and I still have people just refusing to do that. No excuse. G of 3, you can write that and you know what it means. If I plug that in there, out comes -4. That now is my vertex. My vertex had an x of 3 and the y came out to be -4. So now I can graph that point. I can see it's got an a value of 1, so it's right 1 up 1, right 1 up 3, and right 1 up 5. 1, 2, 3, 4, 5, right there. And there's a beautiful looking parabola. And I've answered all the questions except for vertex form here. A times x minus h squared plus k, but I know my vertex right here is at 3, -4. So y equals a, which is 1, x minus 3 squared minus 4. All done. There's a demo of it. I'm going to run through these without doing as much talking. X-intercept. So I'm just going to grab x plus 3, set it equal to 0, solve. -3 is one of them. I'll set x plus 7 equal to 0 and solve that. There we go. I'm going to find the axis by adding my x values together, or the intercepts together, and dividing by 2. There we go. There's the axis. There's the intercepts. I start to graph. -3, 0, -7, 0. Axis is symmetry right here at -5. And vertex going to be at -5, f of -5. So I'm going to plug in that -5. -5 plus 3, -5 plus 7. I add inside, and I multiply. And so my vertex is at -5, comma, -4. Boom, boom, boom. Over 1 up 1, over 1 up 3, over 1 up 5. There is my curve. Exercise 2 here. So this is for you to practice again, but here's the work for it. To have to catch up, x plus 4 equals 0. So x is -4. So -4 comma 0. X plus 6 equals 0. Solve it. X is -6. Axis is symmetry. -4 plus -6 over 2 equals -10 over 2 equals -5. There's -4, 0. Here's -6, 0. That's not -6. It's right there. And there's the axis of symmetry. On the vertex, it'll be at -5, comma, f of -5. So I'm going to have to plug in -5 into the function. Got that 2, -5 plus 4, -5 plus 6. Do what's in parentheses first. Multiply, doesn't matter if you go left to right or how you multiply, but I come out with a -2. This has a stretch of 2, so when I go right 1 here, instead of going up 1, I'm going to have to go up twice that. When I go right another one, I'm going to have to go up 3 2 times. Put me up here at 6. And I won't be able to squeeze in another point because I'd have to go up by 10, and I don't have enough room. There we go. Exercise is done. Hopefully you can do that on your own. All right, demo 3. It's the same thing, everybody, except no graph, right? But you're still going to sketch one to help you figure it out, help you think about it. So, a couple of things here. The first one is this kind of in a wonky form, okay? But notice the x is outside. There's no x squared inside here. It's an x times this. This is like your intercept form, okay? This is like x minus 0 times x minus 4, but x minus 0 is just x. And then they usually drop the parentheses because it's just multiply. All right, so there's the original problem, but you can see it looks like vertex form. When you write it and think of it like this, then right away you can say, well, it must cross when x is 0 and y would be 0, and when x is 4, y would be 0. In other words, I took the x minus 0, set it equal to 0, but that just gives you x is 0. That's this one. And I take x minus 4, I say, hey, what makes you 0? And I solve it, and it tells me x is 4. That's that one. So like in general, when I look at this problem, and it's just experience, but get used to it. If x is a factor out in front like this, and it's a quadratic, that means x is 0 is one of your x-intercepts. All right, so I'm going to draw this thing real quick here. It must have an x-intercept at 0 and at 4. So let's write those down. Intercepts 0, 0, and 4, 0. There we go. Axis of symmetry. Add those two numbers together, divide by 2. It's right where I thought it was. Gotta find the old vertex now. I gotta find the f of 2 here. Take this number and plug it in. That's not bad because of the structure of the equation. It's a pretty easy one to figure out. -4. There's my vertex. When x is 2, y is -4. X is 2, y is -4. There's my vertex right there. See, no stretch, no a value. A of 1, I guess. So right one up 1, right one up 3. 1, 2, 3. Yep, that's them. And so I have a pretty good sketch. This thing has a minimum of -4. The y-intercept is 0, 0, right? It's crossing the y-axis right there at the origin. So I'm done. All right, here's an exercise. Why don't you pause your video and you can try that. If you're done with that, here is now. Hey, this is just like the one I did. X is 0 is one y-intercept. X is -7 is the other one. Just, hey, what makes this one 0? What makes this one 0? Only works when you can have it structurally written like this. And we can have it that way, so I can tell the solutions right away. Alrighty, so now graph 0, -7. Ooh, this is not going to be pretty because that means my axis is going to be some fraction here. Okay, I can find him. I just take my x's, add them together. -3.5. So there's the axis of symmetry. So we got x equals -3.5. We got x-intercepts at -7, 0, and at 0. 0. This thing opens upward. So I just got to figure out now where the heck this darn thing starts on the y-axis or on this axis of symmetry. So I'm going to quickly calculate what the heck is the f of, let's see, -3.5. So I have to do 3.5 plus 7, which is 10.5. So let's see here. That's 35 plus 1.25. It's like 36.25, I think. I'm not quite sure about that, so I'm going to grab my calculator here. 3.5 times 10. 36.5, 36.75. I thought I was off by a little bit. There we go. So my vertex, when x is negative 3.5, must be up there at 36.75. So way up here. And that can't be right, because that would make it open upside down. I must have a sign here wrong. Let's see here. I should be plugging in a negative 35. Crud. Or negative 3.5. Negative 3.5. There we go. Negative 3.5 times 3.5. That's not going to be 36 point something. Let's get rid of that guy. 3.5 times 3.5 is now like 10 point something. 9 plus a 1.75. 10.75. 3.5. Let's clear that up. Clear that up. Try 3.5 times 3.5. That didn't work. 0.5 times 3.5. 12.25. And that'll be negative. There we go. So my vertex is at negative 3.5, negative 12.5. Think we're doing all right on that. Let's see here. Y-intercepts. Holy cow. Let's go ahead and finish graphing this thing. So negative 12.5 is down here somewhere. So there we go. So this one clearly has a minimum of negative 12.5. X-intercepts, check. Oop, got to find my y-intercept. To find your y-intercept, it's always the same thing. Find the f of 0. Oh gosh, that's 0 times 7 is 0. Oh yeah, it does cross right there at the y, or at the origin. So that's a y-intercept as well. All right, number 4 here. A little bit tougher problem, but it's in a times x minus p times x minus q form. So p is 4, q is 6. No, q is negative 6. Those are my intercepts, so my x-intercepts, 4 comma 0, negative 6 comma 0. I'm going to type that in so you can see it. I've got it in function notation here. I'm going 1/2 parentheses x minus 4 parentheses x plus 6. Right, I'm going to tap these x-intercepts so you can see them. There we go, negative 6, 0, and 4, 0. Now our axis of symmetry has to be right between those two. So I add them together, divide by 2 to average them. Looks like it should be at x equals negative 1. So I'm going to graph that thing so I can see if it goes right through. Oh, yeah, it goes right through the center of my parabola, doesn't it? There he is. Let's see. So there's my axis. Now I could steal my vertex at this point because I got it all graphed. Negative 1 gives me negative 12.5. Looks like I just had that problem. Interesting. Fx minus 4x plus 6. I'm going to grab that other one real quick. X times x plus 7 just to make sure I did that one right. Oh, look at that. Got exactly the same vertex, y value. Very cool. All righty, let's finish this thing up here. So my vertex I do know now. It's negative 1, comma, negative 12.5. But again, I didn't really calculate that. I just found that with my Desmo. So I do want to show where it came from. I put in the negative 1, and you should do this as well. If you're solving this on a test, say, this is how I found it. Now, you could type this into a calculator and just spit out the 12.5 or negative 12.5. I'm going to go ahead and work it out. Half of 25 is 12.5, and it'll be negative. And finally, our couple of things here. This thing has a minimum of negative 12.5. And finally, y-intercept, I got to put a darn 0 into this equation. All right, so I'm going to put 0 in, f of 0. 0 goes in, 0 goes in, and so it would simplify to like 1/2 times negative 4 times 6. I'm going to multiply those together. Half of negative 24 is negative 12. So y-intercept when x is 0, y was negative 12. Here's another exercise. You can pause here real quick. Try it on your own. All right. Now here comes how to solve it. I'm going to grab my x-intercepts here. X is 4. X is -6. I'll find the middle of my two values. I'm going to find the f of -1. That's a 25. There we go. So my vertex is at -1 comma 75. Now I don't trust that a whole lot. I think that seems awfully high. So I'm going to graph this guy real quick. Parentheses x -4. Now, the fact that he's stretched like that doesn't mean I'm wrong. In fact, it's got a 3 out in front of it. So it's going to be upside down, a -3 in front of it. And it's going to be really stretchy, really thin. So there he is, that green one right there. It's way up here. Let's see if it's right. See if it's up there at 75. Holy cow, it is. So -175 is my vertex. As long as I'm in there, let's grab that y-intercept. 0 gives me 72. Let's show some math for that y-intercept. What's the f of 0? It is -3 times 0 minus 4 times 0 plus 6. 12 times 6, hey, that's 72. Check, 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 check. And this has a max of vertex is at 75. There we go. All parts done. Rewrite this thing from intercept form into standard. So from this form into this form. See here, all we're going to do is distribute and distribute and distribute and distribute and add like terms in the middle. There we go. We just written what the f of x is in standard form. Let's see another demo. Oh, I'm just going to multiply these together. 2x cubed minus 10x minus 3x plus 15. 2x cubed minus 13x plus 15. Be your final answer. This I should put y equals. Actually, I should put f of x equals. Right? They want me to take f of x and rewrite it in that standard form. Exercises here. I'll pause and let you can pause the video. Jump pause. Let's just go ahead and distribute this. Double distribution, x getting distribute, x getting distribute again. Second time, -5 gets distributed, -5 gets distributed, add like terms in the middle. And you are done. Same thing. I'm going to do the x plus 4 times the x plus 4 first, giving me this, giving me this. Distribute into 3, giving me this. Basketball is kicked in the following path. So a couple of things. This would be called its initial height, also known as the y-intercept. There's the highest point, or the maximum of the function. And then down here we got when I land, right? So the ball's gone up in the air, come back down and landed, or final height. So if I look at this, now thank goodness they gave me this equation. We're going to use our calculators extensively for this. So I think I've got these all saved right here. This is, I don't have this one in there. So let me just pull up a new graph real quick. I'll graph him. Negative 0.142. Negative 0.142 x parentheses x minus 24. Hard to see him, but there he is. This graph actually makes no sense. There, I gotta get my parentheses right. The graph made sense, everybody, but it was upside down for what was being done to it. Something was goofy. It was below the y-axis, so we are getting negative heights, or below the x-axis. So there we go. There's the ball. It's been thrown from ground level, which is 0, 0. Why is it 0, 0? Because I'm 0 distance from on the x, and I'm 0 distance on the y. Then it goes up here to its max height. So let's go ahead and do our x-intercepts. We'll fill these in. I got one at 0, 0, and I've got one at 24, 0. Is during the maximum height of the ball. There we go. Max height is, or height max, 20.448. See, go to 2 decimals, so we'll call it 49. This is all measured. It doesn't say, it does feet. Determine the height of the ball when it is 15 from the origin. So I could just trace it until I get to 15 here. Just got my finger on it. There we go. 15, it is 19.17 high. Oops, H. So that was 18. There. Not do this without moving your finger a little bit. $15.336, I think it comes out to. But I'm going to find that out a different way. I'm going to just type this in here, negative 0.142. I'm replacing the x. I'll go times the x value, which I think is, which I know is 15. Parentheses, 15 minus 24. 19.17. So what's going on there? Oh, I was looking at 15. 18. I should be looking at 15 for my x value. Sorry. My bad. I stopped there. 15. So there you go. 19.17. There we go. So let's correct that to 19.17. You can see it's obviously easier and quicker to just do this on your calculator. All right, that's it for your notes. The rest of this thing is practice, and you'll be able to check those things out when you go into our Google Classroom.